Alright, it's Rocky again with ICCRP on the E.M.P Pixie channel. Today we're going to be looking at diminishing returns when using soft RAID in macOS. I am using macOS 10.12.6 Sierra, and as some know, there's some quirks to the disk utility. Let me explain it really quick. When I actually go into format and remove drives, you actually have to unmount it first before you can format it, otherwise it fails and yada yada. So now that we've discussed that, let's get on to the testing. We have 4 drives here. They're not matched, so there's 2 of them that are, the other 2 are not. So we're going to see what happens. Here we go. Let's go ahead and start with the first drive. It's Mac 1. We're going to go for that. And let's start the test. It's like 79. And 90. You could call it 91 if you want. Let's do that round up. We got 87. And 91. It's 88. And 87. We'll do about 3 or 4 on each drive depending on how consistent it is. 87. And looks like 90. Alright. So that drive, we'll go ahead and put it down for, let's just, let's give it the benefit of the doubt what the top speeds for its read and write are. Let's go with that. Or instead of approximate average, top speed. Okay. So on drive 1, our top speed on the right side was 88. Our top speed on the read side is 91. Alright, there we go. So let's go for our second drive. Mac 2, open, start. Looks like we got 71. '82. '79. '83. 77. And 83. Ooh, 78. Not bad. And 80. Okay, let's go ahead and conclude that. Our top speeds for that drive are 79 and 83. So a little slower than the other drive. Okay, much slower in certain degrees there. Let's go for our next drive. We have disk 2, Mac 3. So we go there, And begin our test. And this is these last two drives are Hitachis, so they are actually noticeably slower than the other two. So we got 52. And 59. $57. And again 59. $57 again. Pretty consistent. 59. It's like 57 again. Make that very consistent. And once again, looks like 59. Alright, let's conclude that. Mark our numbers down. So we got 57 and 59. Now our second Hitachi. Mac 4. Open. Start. Looks like 53. And 60. Looks like 59. And again 60. Oh ho, we got 60. Looks like again, no, that's 61 this time. Ooh, we got some good numbers on that. 58. And 61. Okay. So we have 60 and 61. Oops. Now let's start creating our RAID pairs. Alrighty. We're going to put together 1 and 2. So we're going to dismount 1 and dismount 2, and then we're going to go ahead and RAID those. We're going to stripe them. So 1 and 2 right there. Next, we're going to call this RAID 1, 2. Next, create. I'm just trying to use default settings to kind of give a pretty consistent baseline, not doing anything special or refined, in the hope of seeing some lucrative results. And we've got our first RAID. Now let's do our second one, which will be the combination of 3 and 4. Oops. Once again, striped. There's 3, there's 4. There we go. All right, we got our, oh, that bothers me. We got our two RAID sets created. All right, let's test 1 and 2. I may actually have to change the permissions, but we'll find out. There we go. Looks like 145. 165. 153. Again with the 165. 155. 165 again. 155 again. Hey, there we go. And it looks like once again we're going to get another 165. Ooh, 166. Alright, so there we go. Did our 4 passes, and it looks like we have 155 and 166 compared to our mathematical combination of the other one. Hold on. Got to get my calculator up. Real quickly here. Little Mr. Calculator. Okay. So we have 1 and 2, which is 88 plus 79, 167. And 1 and 2 again, 91 plus 83. 174. Okay, so that's our recorded diminishing return. Now let's look at RAID 3.4. which has a much closer matched performance. $106. $118. Looks like 115. And 117. $115 again. Looks like 118 again. $113. And again 118. Okay, let's record that. We had 115 and 118 compared to 57 plus 60, 117. Plus 61, 120. So there we notice an even lesser loss in performance on two much more closely paired drives. So now we're going to find out what happens when you pair a slower drive with a faster drive. Will you get additive performance due to the theoretical way that striping works, kind of like a candy cane, it's going to stripe across the drives, or do you get diminishing performance because the drives try to match each other so they can write at a consistent pace? So now we're going to find that out. So let's pair our 1 and 3. First we got to get rid of these RAIDs. Delete. There we go. And delete. Okay, there we go. Alright, now let's put this back together. Let's see, 1 and 3. So 1 is supposed to be disk 6. That's that one. And 3 is disk 2, which will be, let's do like this so we know which one's which. Alright, that's disk 5. This is disk 4. What? It's supposed to be disk 2. It's one of the Hitachis. Where is that at? There it is. Disk 2. Okay, so we're going to format this so that I understand which is which. This is actually Mac 3. Oops. Because the two Hitachis look identical in the RAID list, so I've got to be able to tell them apart. There we go. We'll unmount you. Now we'll create our two RAIDs. So the first RAID is made up or comprised of there's the Toshiba and the Mac 3 Hitachi. Next. RAID 1 and 3. Next. Okay. Now we're going to create our second one, which will be of, no, we need to generate, this is disk 4, so I need to format that so I know which one that is. Should have thought of that. Mac 4. Nice. Okay, now I know which one that is, and we'll unmount it. Time for the RAID assistant again. So now we've got the disk 4 Hitachi and the Seagate. So, next. Just noticed that I might have been able to extend the display and not have to have done what I just did. 2, 4 with the whole formatting thing. Anyway, next. Create. So let's see what happens once this gets done. Okay, here we go. Alright, let's get to testing. So, RAID 1 and 3, a combination of those two. Let's go ahead and tester first. And here we go. We have 105. And 118. 115. 116. This is looking like it's pairing the speeds together. So 115 again. 117, no, 118, excuse me. 113. 118. Interesting. Okay, so this one we got 115 and 118, which looks identical to what we got with 3 and 4 together. So it's making me think, because it should have been, let's see, 1 and 3 is going to actually give us results of 88 plus 57, 145, and 91 plus 59, 115. It's a huge loss, but I do not believe that that has anything to do with a diminishing return. I think that has more to do, well, I mean, diminishing, it is kind of diminishing, but I don't think it has to do with the soft RAID's performance per se. I think it had more to do with pairing those two drives together. It looks like what it is doing is utilizing the speed of the slowest drive for the entire RAID across. So whichever drive is slowest is going to determine the maximum performance of all drives, and therefore slow everything down. So in this next case, we're going to be pairing and testing 2 and 4. Well, 4 is much faster than 3 was, by a little bit anyway. So I think we're going to either see at least the 115, 118 number, or it's going to go up just a step, you know, like a stair step above, and be more in the, I would say probably 117, 120 range, maybe a little higher than that. Let's find out and see if my hypothesis is correct. Which means then we could extrapolate out what we should anticipate to see with 3 drives and 4 drives based upon the drives used. So there's 2 and 4. Get that going. Looks like 110. 120. I think we're going to see my numbers come true. 118. And 121. So far it's starting to prove me right now. 119. And 120 again. Or, yeah, 120 again. 120. 122. Alright, let's go ahead and end that. Let's record it down. And just by the looks of it, I think I was right. So our max here is 120. And we had 122, which is just a step above our prior scores. So therefore, the slowest drive determines the speed of all drives. It has proven me correct so far. So let's see, 2 and 4 is 79 plus 60. 139. And 83 plus 61. 144. Now, interestingly, as you can see, there is little difference between these. I mean, there's a very little difference. This one is obviously slower, and it had the slowest drive out of all four. This one has the second slowest drive and had the second fastest. So this one had the fastest drive and posted the lowest. This one had the second to fastest drive and posted higher. Over here in the numbers, you can see the difference there. So it definitely looks like the slowest drive is going to determine this. My guess is we could extrapolate these numbers even more and say, all right, this right here, because what is this? 115 and 118? If we were to multiply our slowest drive, 57 and 59, let's say, what's 57 times 2? 114, so we're just a hair above that, which is within the margin of error. So we did not have any diminishing returns from two drives on the right, and our other number is 59 times 2, 118, right on the money. We had 0 diminishing returns so far, so that means we can extrapolate out. If we have 3 drives, including the slowest drive, our slowest drive will cause a return of, let's say, 57 times 3. 171 is what I anticipate for the inclusion of our slowest drive, which is sitting in 3. So this, I'm going to say, should be 171, putting an asterisk there, and the 59, let's see, 59 times 3, 177. Asterisk. The real possible number, well, the other number, for these 3 drives, we have 1, 2, and 3, which will be 88 plus 79 plus 57, 224. We are not going to see anything close to that because we've already proven slowest drive rules. 91 plus 83 plus 59, 233. And I'm going to go as far as to say, if that is proven, we're going to have the exact same numbers right here. We're going to see 171 and 177 again. We'll see the exact same numbers because once again in 2, 3, and 4, well, guess what? Number 3 is our slowest drive. It's included in both of the sets, and I believe we're going to see the exact same results between the 2 sets. However, the difference based upon individual drive performance is going to be quite different because you have on this one 79 plus 57 plus 60, 196. In the second set, you're not including the fastest drive. You're including both of the slower drives, whereas in the first set, you were including both of the faster drives. 83 plus 59 plus 61, 203. These are very, very interesting results. Okay, so far anyway. Let's get to it. Let's create our raids. well, our first raid, because we're going to actually have to get rid of both raids and then generate a new raid in each test. So this first one will not include both Hitachis, but it will include both of the other ones. So let's see if my other thing I noticed will do me any good, so I don't have to create that little, oh, this is what this is drive. Assistant, striped. Aha, it will. Good. That's what I was looking for, these disk numbers. Okay. So 1, 2, and 3 will include disk 2. The only disk it's not including is 4, so skip over that disk 4 Hitachi. There we go. That is RAID 1, 2, and 3. There we go. Alright, let's do this. I'm excited to see the results. Okay. Start your engines. See what we get. So far, 164. And 175. $175. Ho ho. And 177. Oh, looky there. Looky there. 173. And 176. $175. Again. And 176. All right. Theory proven. Just as we saw earlier, where this number actually was more than double, we actually saw an increase here, as we should have, and it actually turned out to be 175. We saw a noticeable increase on that one actually. So the right was the right was much faster than anticipated, and this one came in right on the money. Because as we saw before, 2 times 59 is 118. So the slowest drive rules definitively on the read, and we lost nothing. There was 0 diminishing return on this. If we had matched drives, we would probably see 0 diminishing return on this, and that's with a RAID 0, 3 of them striped together. So I anticipate to see similar results, actually identical results, on this one. The right might be a little bit slower because we're going to incorporate the 2 slowest drives and one of the faster drives. So it might not have as much of a improvement in the right, but it's definitely going to be close, if not right on the money, the same. So let's go ahead and test that now. Let me clear that out. This is getting exciting. And that also means that Apple has a very effective software RAID that they created, the utility anyway, or the format, how it works. Let's put it that way. That it's actually quite effective. So we're going to go ahead and create our new RAID, which is going to incorporate our. This one will incorporate both of the Hitachis, And our friend disk 5, which happens to be the Seagate. We're excluding the Toshiba. RAID 2, 3, and 4. Alright, let's test this. I'm excited to see these numbers. It's getting exciting. Here we go. $163. $170. Slow start. $173. There's our 177. Yeah. And we actually have almost. Oh, we're getting close. 174. And 176. Come on, 175. Ooh, we got 174. So it's a little slower on the right. But we are holding at 177 for the read. Oh, it's beautiful. Beautiful numbers. 177 predicted. Yes, right on the money. This one, not as fast, did not incorporate both of the faster drives as it did before, and it's still well within the margin of error. And we came in at 174. So, with that hypothesis validated and vindicated, then we can say, let's extrapolate this. I'm going to say double what our base speeds were here. Actually, it'll probably be above that on the right, because we're going to have both of the faster drives incorporated in this. So the right will probably be faster than 230, which would be double those. Or excuse me, double that number. So I would say this is going to be at least 230. I would be thinking, I think it's going to be more around 235. I think we're going to see a really nice positive return. And then on this one, this is going to be at least, or should be right on the money. Let's see. It's an awkward number, so I'm going to cheat. Okay, times 2. 236. We should see 236 on this. And our other numbers, just to keep consistent with what we've been doing, let's just go ahead and add into this 224 number the missing drive in that equation, which is Mac 4 at 60. So that should be 284. So it was kind of good that in this testing, and let's see here, 233 plus the missing drive, 61, 294. It was kind of good that I didn't use matched drives in this, because it is giving us some insight into how it works and what kind of performance we can really see for utilizing these RAIDs, especially with mismatched drives. Now keep in mind, if you start building these weird RAIDs that use bits and chunks of one drive or another, you're going to see some really crappy results, just because you're going to wind up having the disk get hammered by multiple different reads or whatever you want to say. But anyway, I digress. I'm excited to see this result, which will vindicate some very important information. And why do we not have that drive? Okay, hold on. Gonna have to close this again. So cut disk utility, because disk utility blew up in its own face. Almost the disk utility. Yeah, here we go. All four. And next, all four drives are now included in the RAID. So with our current trend, we should see no diminishing returns and be the slowest drive times 4, basically, on the read, and close to the slowest drive times 4, actually above that, because it does write slightly faster, which makes sense, actually, for the write. Which this is very positive results. Oops. Okay, we're just gonna say ignore. That was weird. I didn't even... Oh, it was very strange. Okay. Yeah, I don't see any special drives in there. Whatever. Alright, let's do this. We'll get straight to the testing. Ignoring the error that we had there. Might have just been I had an external drive plugged in or something and it just re-recognized it. Or it was acting strange. Who cares? Start the test. I want to see some performance here. As expected, we're having a slow start, so 2:15, which seems to be the trend. 2:35. We're already up there on the read. Oh, look at there. Look at there. Looky there. 2:32. Oh, and the read is going up. 2:36. All right. This is very promising results. 2:29. And 2:35. Yeah. We are seeing the numbers we should be seeing. This is great. And then, of course, there's some weird oddball number. What the heck happened there? 127, 128. I don't know what that's all about. Something else might have been using the drive. 2:35. We're going to give it one more run because that was really strange. Just to make sure it was an anomaly. And it was 2:32. And 2:35 again. Yes. Theory proven. Well, hypothesis. Alright, we saw a max of 2:32. As we anticipated, it was at least or above 2:30. And our winner at 2:36 was the read. So, as expected, we have 0 diminishing returns. Or, if there is any diminishing return, it is so negligible, even with 4 drives, that you don't see it in the performance results. Interesting results. Interesting test. We learned a few things along the way. And I look forward to, at some point, feel free to please, donate to my Patreon. I plan to, once I have enough funds, purchase 4 SSDs and push it to the limit by maxing out the SATA 2 on my Mac Pro with 4 SSDs running at their full potential, and once again run this very same test and see what results we get. So, please like and subscribe, as all the other YouTubers seem to like to say. And this has been an ICCRRP production. Thank you, and have a wonderful day.